Welcome to clickmyproject.com. Now we discuss about the product for FPGA hardware based implementation of an image watermarking system. Next we see the abstract for the product. The digital watermarking is a method used to hide the embed unique information into a digital image that can be uniquely identified later for its connected and the authenticately. Digital image is an image that can be constructed and rendered by the use of electronic devices such as the computer. Watermarking key or a data is the information being added and embedded into the original image to be used to identification purpose. Encryption is the method to alternating a digital to prevent any unauthorized interception and modification while the transmission. Therefore both watermarking and encryption are needed. The digital watermarking process consists a watermark encoder and decoder. The encoder adds and embeds watermark onto a host object and the decoder reconstructs and identifies the content and authority of original digital image. This process is done to using the unique key. The key is private and known only authorized parties, eliminating the possibility of illegal usage of the digital content. Watermarking can apply in the spatial domain and frequency domain. The discrete cosine transformation theory was used to digital watermarking system and to modify the DWT based methodology for in this work. A robust ability to modify the watermarking scheme based on our digital discrete wavelet transform for copyright protection is presented. The original unmarked image is not required for a watermarking extraction. Third level DWT is applied to original cover image. Third and second level horizontal detail subband coefficients are grouped into different blocks. For watermark extraction or a threshold based decoder is designed embedding an extraction process are characterized with parameters. The objective of this paper to implement an algorithm of digital watermarking technique applied by hardware platform to platform fast processing and provide the portability. Several software based on the encryption and watermarking technique exist and are used to currently in the watermark. However, the hardware implementation are not commonly used to their complexity and cost. The design is used in this paper implementation of both watermarking and encryption technique. This on the field programmable gate array devices. Next we see the flow diagram for the product. Our input image or video samples are to be applied for our inputs watermarking system. The image to be directly passed on the image signal or the video first frame to be convert the image. This is our the input image for the watermarking system and apply the DWT transformation methodology to be processed in our image or video first frame. This DWT transform mainly consider for the construction, decomposition and threshold methodology. The decomposition method to be applied for first process and to apply the threshold level, then to get the reconstruct over the overall information, then the host frame process to be input for our embedded section, then the watermark image to be selected for the any one of the watermark image, then the watermark vector level to be passed in our estimation. This is the most estimation for to be converted for the input video processing and to embed the watermark image to first frame or first selected image to be embed for our the embedded processing, then to get the inverse DWT transfer. The embed to be applied for the threshold region for our watermark image, then the input selected image. This is our the inverse DWT transformation method to be reconstruct our the overall information work. These works are to be placed in our Xilinx process and the conversion process, then to display the frames and the reconstruct the frames and images to be for MATLAB work. This is our the watermarking system processing for overall architecture level. Next we see the final output for the product. First we run the overall main function for our process. These MATLAB functions mainly used to initialize the image and select the any one of the image format, and to initialize the given image and to display, then to write the pixel point into separate text format. This text format to apply the our Xilinx process. So we select the any one of the cover image, and next to select the any one of the input information image, then the information image and to cover image to be displayed for overall process. Then to run the Xilinx IC project, this project navigator mainly used to open the DWT transformation process. This DWT transformation process mainly applied for signal decomposition and threshold region, then the reconstruction, then to inverse the inverse deduplication process, and to run the output to output pixel points to write the separate text format. This text format to retrieve the our MATLAB function, then to select the overall architecture process. This DWT transformation function to run the our overall process, then to simulate the our simulation process, then to complete the simulation process, then to open the our iSIM project navigator process. This project navigator to apply the clocking signal transformation for to transform the our overall process to be running in our the final process. So that's why to be processed for a undefined process to be simulation work. Then to close the simulation process, then to select the our processing results. This is our cover image for watermarked image for original information, and cover image to be embedded image. Then to display the our retrieved original image. This is our comparison performance for MSC and BSNR value for watermarking system. This is our input or output value for MSC and BSNR values for our the watermarking system using the FPGA based process. This process to optimize the circuit complexity and processing time for overall watermarking operation.